since I know everyone is ready and everyone is now paying attention, are you ready this time? All right, so class.
Yes.
Okay, good. I got a yes over here. Where's your yes?
Yes.
There we go. Karen? Karen? Okay. Jenny? Big Mac? At least get a yes, not a what. Come on now. All right, so we're going to go through here, and what page in my notebook are we on?
41.
41, right? So it's 40 and 41 where the homework is going to end up on page 40. The notes are on 41, so we're going to go through and talk about these things. Now, a polyhedron, it is a 3D shape with a bunch of sides. Poly, the prefix of the word, is referring to many. Hedron was referring to a shape. So this is many shapes or many sides for this to actually be the actual whole word. Anyway, identify name and solid figures. So three-dimensional shapes are called solids. We normally refer to this when we're talking about volume, because we have a shape and how much liquid that we could have in that shape. So these are solids. When a solid is formed by polygons, the solid is called a polyhedron. Now, a polygon is referring to many sides. Okay, that refers to a 2D shape. So this one is a 2D shape. And if we put a bunch of them together, we get a polyhedron, which is a 3D shape, which is 3 dimensionals. Hopefully that makes more sense.
Yeah.
A little bit? Yeah? Okay, good. All right, the plane surfaces of a polyhedron are called faces. The segment joining the vertices of a polyhedron are called edges. So in between, so let's say for instance, oh man, I actually had a cube here for this. Let's pretend like this is actually complete. This box is complete, okay? So, yeah. Ignore the fact that it's missing a side. So, this right here is that would be a polygon, and in the whole shape, it would be referred to as a face. Face. This one's a face. The whole thing together would be the polyhedron, okay? And segments joining two vertices of the polyhedron, so that would mean this line right here is referred to as the edge. The line right here connecting the two faces is the edge. Two bases of a prism are congruent polygons in parallel planes. So now, that means that, see the top right here and the bottom right here? These two, if they're congruent, then these two are going to be the parallel top and bottom. Left and right are also going to be parallel in this shape right here. And base of pyramid is a polygon. Now, a pyramid, you guys know, goes to a point. Yeah. The base of it, so whatever shape is going to be at the base, as long as we not keep staring at our phone for some reason, it's almost like you lost your mind. But anyway, so as we're going over this, so you can see, and see this pointy point?
Yeah.
This pointy point right here is referred to as a vertice. The pointy points are vertices. Big Mac, is that what you were looking for there?
Oh.
Yeah, you were looking up that one right there. Google Maps. Okay, vertice.
Nope.
Okay. Okay, anyway. Says, identify and name polyhedra. Tell whether solid is a polyhedron. If so, identify the shape of the bases. Then name the solid. Now, this one right here. Does it have a polygon for each one of the sides? Say no. No. Can anyone tell me why?
Because it doesn't have a force.
It's what? It's round. It's round. The polygons actually have a bunch of the sides, but none of the faces are going to be round. None of the edges are going to be round. You don't have any curves on it. So, because this one right here, if it were to cut off right there, and it would be that three-dimensional shape, then I could say that that one would be. So this one is not a polyhedron because it is round. Now, this next one here looks like, so what shape do we have right here? No. Star, it's not a star. Okay, we identify everything by whatever the base is. Think of the shape of the base and just make it tall. The shape of the base would make it tall. So this right here is going to be the same as the bottom right here. Not octa. What does octa mean? 8. So is this one 8 though?
No.
How many sides does the polygon have? 5. 5. 1, 2, 3, 4, 5, right? Okay. The base has 5 sides. That is a penta. Okay? That is a pentagon. Okay? So, this is, since it's going straight up like there from there, so it's a pentagon that is tall. So just think of it like that. So it's a pentagon that just, goes straight up from there. So this one would be a pentahedron or pentagon. So by the shape of the bases. So my pentagon is the bottom shape right there, and then it turns it into a polyhedron because it makes it a tall pentagon. Does that make sense or no? Kinda? Leo? Did you write that one down? Okay, you probably should. All right, so let's see if that makes sense. Let's look at question 1. Leo, is question 1 a polyhedron? No? Why?
It's like round.
Very good. It's not. So it's no. It's round. Okay? It's rounded. It's got curves. So that's a no, right? All right. Tuka. Question 2. What do you think? Okay, so is it a polyhedron?
Yeah.
Okay, good. Now let's identify the base. So the base, because the way this is shaped and they turned it, yeah, it's going to be long, right? But it's going to go like this, right? So this would be the base right here. Yes? And it's going tall. So that's 6 sides, right? Do you know the 6 sides? Hexagon? You said hexagon, right?
Yeah.
Yes! You said hexagon. Good. So this is a hexagon. So this is a hexagon, is my base that is tall because we have another hexagon over here. Right? Okay, good. So we get the hexagon for that one. Now the next one. 3. What do you think? Yes or no? Good job. It is yes. Now, what is the shape of the base?
Square.
It's a what?
Square.
It's not a square.
Right. Triangle.
It's a triangle. Very good. It's a triangle because you have to look at the way it goes. It is a shape, okay? So it's a certain shape that is tall. So this one right here, we have a right triangle right there, right? And there's the other side. This one is, you notice it's turned over on its side again. So this one is my triangle. So the shape of the base is a triangle. And then it is a tall triangle right there. All right, go ahead. I know you want to.
Yes.
You say yes, okay. So, what's the shape of the base?
No.
You don't know? Yeah, it's a rectangle. So this one, it actually is, it looks like it could be like this. This is the 3D image of it. So it's a rectangle. It's the same rectangle on top that is tall. Yes? Just a tall rectangle. Does that make sense? No? Maybe? Kinda. On occasion. Only days that end with Y does that make sense. Find faces and edges. So, let's see. Use the diagram on the right. Name the polyhedron. So, first, I need to identify what shape is my base.
Triangle.
Yeah, triangle. So I have a triangle here. I have a triangle, right? I have two triangles. So the full name for this one, TRIA. So we just name it with the polyhedron after it. All right, let's count the number of faces. Count the number of faces.
4.
3.
1, 2, 3, right?
Yeah.
And top and bottom?
4, 5.
4, 5. Very good. So it has 5 faces. And then how many edges? And I'm gonna, if you go through and do this, it makes life easier. You said what? 6?
6. I think so.
You think 6. Okay, let's see. So I'm just going to trace over each one and count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, no, maybe? Now, off to the side, I'm going to do the last part right here. List congruent faces and congruent edges. There you go. All right, congruent faces, congruent edges. Now, the face right here, this triangle, we could say triangle ABC is going to be congruent to, which triangle is congruent to that one? On the bottom, right? On the bottom, so that would be triangle DEF. Okay, what about my sides? It looks like the sides are going to be all congruent to each other, right? Because there's a tick mark there, a tick mark there, a double tick mark there, double tick mark there. So it looks like every single one of the sides has the same thing here. So every single one of those sides are going to be congruent. So that would be plane, let me see, A, C, F, D, congruent to, that would be, it's ACFD, CBEF, and that's going to also be congruent to the last one, which is BADE. And now the congruent edges. There's a lot of edges here that are going to be congruent. And now I'm going to change to a different color here. So let's see. So all the ones that have the double tick marks are going to be congruent to each other, because that's what the symbol means, that the all double tick marks are congruent to each other. So we could say AD is congruent to CF, which is congruent to BE. Those are all the double tick marks. AD, CF, BE. I'm sorry, my penmanship's not very good. That's why I'm going over it again. So it's AD right here, CF, and BE. Now let's look at all the single tick marks. There's a lot of single tick marks here. We know AB, BC, and CA all have this single tick mark. So I can say that AB congruent to BC, congruent to CA, and those also have the same single tick mark as the bottom, which is down here. So those are also going to be congruent to DE, so DE congruent to EF, congruent to FD. So a whole lot of stuff congruent here.
Why do we need that?
Because it said, list any congruent faces and congruent edges. Okay? We did the faces over here, so we had the triangle on top, then the parallelograms right here, which are the rectangles that we have on the sides. And then we have all the edges, because it said all the congruent edges. Yes, no, maybe? No?
Same, 50-50.
Okay, I got a serious question though, because I don't really know. Did you guys actually do proofs where you actually talked about line segments being congruent to each other in shapes
Yeah.
this semester? Or no, not this semester, last semester?
Yeah.
Yeah, with shapes like two-column proofs. Do you guys know what a two-column proof is? No? Oh, okay. So if there is stuff that that I'm putting up here and you're like, what the hell is that? At least tell me, because I don't know what you guys covered it first semester.
We did this, they forget it.
Oh, they forgot it. You did it though, right? But everyone else just forgot it.
Yeah.
Uh,
We didn't do this.
I know, yeah, we did.
okay.
We forget it.
Oh yeah, no. If you don't know what it is, then you gotta say something. So
I think we know that.
okay,
You don't?
The congruent?
Or you
Yeah.
leave it
okay. The congruent line segments. So right here with the line segments. Okay, the congruent lines. Right here with the faces, with the rectangular face right here.
Because you can't understand.
Yeah.
Can't understand it, or like, can you read it or not read it, or yep. Yeah, go. If it doesn't make sense, say something. Okay, I'm trying not to assume that you guys actually know everything. Okay, I automatically assume you guys forgot everything. That's what I do. I try to. But sometimes I miss some things that, you might have already forgot. Like Leo staring at his phone. He forgot to keep that away. Make sense? No? Maybe? Okay. Karen? You're looking it up? Is that what you're doing? Trying to find a TikTok on how to do those? Okay, good. Name the polyhedron, count the number of faces and edges, and then list the congruent faces and edges. Let's see if you can do that same thing. So what we just did up there, you're doing right here for 5 and 6.
Too much.
Okay, so start off with, name it.
Can you go up?
You want me to go up more?
Yeah.
There we go. Okay.
If there is no.
What shape is that one? Starts with a P, ends in pyramid. Anyone that might be awake.
Triangle.
That guy? You think that
No,
guy's awake?
triangle?
Nope. You. What is it?
Pyramid.
It's a what? Okay, thank you.
But it's shaped like a. This is
Hey,
a
that's cool.
We're talking about the name.
It's a pyramid. It's a pyramid too. It's triangle.
Oh. Oh, you were supposed to bring your mug. I would offer you some coffee, but you don't got your mug. You, that guy. What shape is that? That one. That one right there. That one down. Yes, that. Nope, try again. Starts with the P, ends in pyramid. Is that one a pyramid? I don't know, I can't tell.
Mr. Can you come?
Hmm?
Can you see
Yeah, there's gonna be a bunch of them.
this down, but there's no.
Yeah, there's no. So, does this one have anything congruent to it?
Oh,
The bottom is not congruent to anything.
the bottom?
So the bottom face, the rectangle on the, or the square on the bottom is not. So that one has congruent sides, but it doesn't have a congruent face. So this one's a pyramid. So my congruent sides, so triangle, A, E, D, congruent to triangle.
I did the same
DEC, congruent to triangle EC AED. That's a triangle symbol. CEB, triangle, and BEA. BEA. So those are all the sides that are congruent, or the faces. Now let's look at the segments. So let's go with all the double tick marks. So AE is congruent to DE, congruent to CE, congruent to BE. So those are all the double tick marks going around. Let's go with the single tick marks. Single tick marks would be here, like down here. So we have AD congruent to DC, congruent to CB, congruent to BA. And how many faces does this would have?
Face?
Face.
It does have five face.
5 face. And how many edges?
8 edge.
8. This one, next one would be a rectangular polyhedron. The congruent sides. So we have the different faces. So FJ, J, N, M, G, F, M, L, H, G, L, K, J, J, H, K, N. All right, now we have top and bottom. Top and bottom. now let's go with segments. Let's look at all the double segments. So that would be here, 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 and here. So FM. GL. HK. And JN. So those are all the double tick marks there. Now let's look at the single tick marks, which is along the bottom. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of those. So let's go G. Let's start with GH, HJ, JF, FG. The next one is going to be on the bottom, so that's LK. Congruent to KN, congruent to NM, congruent to ML. And for the sake of your guys' own sanity, I'm going to make sure you guys don't have many of these to do on the homework or on the tests coming up. So, it's easy though, right? But it's a lot. So,
It's gonna waste time.
you think it's a waste of time?
No. I say it's gonna waste time. I don't say
It's going to waste time? Okay. Anyway, down to example 3. So we have Euler's formula relates to the number of faces F, vertices V, and edges E of a polyhedron by the equation F plus V equals E plus 2. Use Euler's formula to find the number of vertices on the hexagonal pyramid shown. Okay, so faces. Okay, F is my faces. So let's see. So if I have 1, 2, 3, 4, 5, 6. I have 6 down here on the bottom, right? So how many faces is this one going to have?
6,
Not 6.
7.
7, because you also include the bottom, right? So there's 6 little triangles and 1 on the bottom. So it's 7 faces. Let's look how many vertices. Okay, vertices is going to be the pointy P equals my edges. Let's do the edges right now. 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10, 11, 12. I have 12 edges plus 2
What is this?
because I got these right here. So how do I find out all the pointy points? So I could do a little bit of algebra, right? 7 plus V equals 14. Subtract 7. V equals 7. So what that is saying is I have 7 pointies. Let's see. 1 pointy, 2, 3, 4, 5, 6, and 7. I have 7 pointy points. So we could use the formula to find missing values. If we don't know how many pointy points, or we don't know how many faces, or we don't know how many edges, we could solve for each one of those variables if you're looking for it. So we're just going to do question 9 and then we'll skip the rest. So a pyramid has 9 faces. 9 faces, so in my formula it'd be 9. And it has 9 vertices. So if my formula, 9 vertices is equal to how many edges does it have? So I just plugged into my formula. Do the math. I get 18 equals E plus 2. What am I going to do to get my E by itself, which is my edges? Yeah, subtract 2 from both sides. So right here, that means that I'm going to have how many edges?
16.
Yeah, 16 edges. Does that make sense?
Yeah.
Just plug in and we can find whatever's missing. So, I'm sorry you guys, I'm kind of dying right here. So, I'm trying not to die on, in the video, but still. I'm having an allergic reaction, so I'm trying not to die. So, anyway, so you guys are going to like, share, and subscribe. The homework is going to be that other page. You're going to do your best to actually try to name those. And some of those are ones that you should have known from previously. 3-dimensional objects. So that round thing, yeah, don't say basketball. What are you going to say that round thing is?
Basketball. Soccer.
Not a soccer ball.
Baseball.
It's not a baseball either.
Sphere.
What do you think that round one is called?
Sphere.
What? Very good. Good job. It is a sphere. So, make sure you guys all get that done, and then I'm collecting notebooks as soon as we're done here.